All right, we are going to talk about sound and how sound travels through the air, or how sound travels through a medium. So sound waves are compressional waves, or longitudinal waves, unlike the transverse waves that are of the electromagnetic spectrum. So the waves that are responsible for us being able to see are different than the waves being able are responsible for us being able to hear. And you know that all waves are formed by vibrating objects, and sound waves specifically are formed by vibrating objects colliding with air molecules. So remember, sound cannot exist if molecules do not exist. So in other words, in space there is no sound, and that's why, because these compressional waves require a medium, and space is not a medium. The molecules are way too far apart, so they cannot collide with each other. Remember, compressional waves are made of two regions. Remember, we have our compressions as well as our refractions. All right, the speed of sound. So how fast sound travels. So the speed of sound depends on the temperature and the state of the medium. So in other words, if you are looking at a solid and a liquid, okay, when the molecules are going to be closer together, sound is going to travel faster. When they are further apart, like in the air, it's going to travel slower. As far as temperature, okay, as a medium's temperature rises, molecules are going to move faster, which means sound waves are also going to move faster. So the cooler the temperature, the slower the speed of sound. The hotter the temperature, the faster the speed of sound. So human hearing, there are 4 stages to human hearing. Okay, the first stage is the ear is going to gather the compressional waves which vibrate through a membrane called an eardrum. So those compressional waves hit the eardrum. Okay, in stage 2, the middle ear has 3 bones called a hammer, an anvil, and a stirrup, and they amplify the sound waves. So in other words, they increase the amplitude of the compressional waves that have been brought in. Then the inner ear, which contains the cochlea, okay, vibrate and send auditory nerve impulses. So again, we're back to the nerves of the brain. And now the brain is able to decode those auditory nerve impulses and process. Okay, stage 4 is the brain decoding and interpreting that nerve impulse. So here is the 4 stages with regard to the structure of our ear. So here's our ear. Okay, so we have our compressional waves. They come in, they hit the eardrum. Okay, they are then amplified through the anvil and the stirrup and the hammer. Okay, and to the inner ear, the cochlea, where they are interpreted or grabbed by the auditory nerves, which send a signal to the brain to be decoded. So factors of sound. Intensity of sound is the amount of energy that flows through a certain area in a given amount of time. So this is kind of a mixture of both frequency and amplitude of the compressional waves. So the amount of energy, remember, is directly related to the amplitude of a wave. So the intensity of sound would be an increase in amplitude of that wave. And understand, if it's going through a certain area in a certain time, we're also looking at the frequency that amplitude is having. Loudness is just humans' perception of sound intensity. So when something is very intensely loud, or has a high intensity, it's going to be perceived as being loud. And loudness is measured in decibels, whereas compared to intensity, which is going to be the measure of energy or amplitude of a wave. And then finally, pitch. This is how high or low a sound seems to be, meaning like high-pitched or low-pitched, which is related to the frequency of the sound waves. So the pitch is going to be related to the frequency. So when it is a low frequency, it is going to sound like a very low thing. So gentlemen, as you get low voices, okay, the frequency of your voice box, the frequency of the vibrations of your vocal cords is going to be low. And if you have a very high voice, okay, the frequency of your vocal cords is going to be very fast. We can hear anywhere from 20 to 20,000 hertz. Okay, anything above 20,000 hertz is called ultrasonic. Anything below 20 hertz is going to be subsonic. Okay, so we can hear anywhere in between that. It's pretty big range. Certain people have better hearing than others. Certain people can't hear different pitches of sound. okay? And that's just a part of what makes you an individual. And the older you get, the smaller the range of pitches and intensities that you can hear. All right, that is it. Please let me know if you have any questions. Thanks.